Morning, everyone. So I had a question about section 8.1a, question 5, where you have this triangle ABC, where angle A is 41.3 degrees, and then the side opposite it is 184.6, called little a here. And we know what another one of the sides are, 248.6. So if we were to go in here, I tried to make a little diagram for us here. What we're looking at here is we have this angle, 41.3 degrees, and its opposite side in this case is 184.6. This is what little a is. And then I just arbitrarily picked this to be side B. We don't know what the angle of that is, but we do know that the side opposite it is this 248 there. So we can use the law of sines to figure this out, where sine of 41.3 degrees over this 184.6 will have to be equal to sine of b over this 248.6. That's what I've written right here. So if we have that, then this is what we're looking at, and we can solve for sine of b by multiplying that 248.6 over. Notice that it gives us over. Again, if you're using Desmos or if you're using another device, make sure you're over in degrees first, so that way it's not thinking of this 41.3 as some kind of radians here. So we know, for example, that sine of b is going to be equal to this, right? So that 0.888 thing right here, this is what sine of b is. I'm going to go ahead and put that in now while I've got it. And notice that it says you need it to at least 5 decimal places. I definitely gave every decimal point that that sine of b has, but let's make sure we've got that sorted. Now the key here is that we know that sine of b is positive, and that creates two possible angles here, where one of them is going to be where when we are to figure out what b is, it's going to be in the first quadrant where sine is positive, but it could also be in the second case. So that creates an ambiguous set of cases for us. So if we were to go in the first case, it would look something like this. But if it was in the second case, well, then that means b would be between 90 and 180 degrees. So it would look something closer to this here, right? So we'd have something where this angle is more than 90 degrees through there, right? So 90 to 180 degrees. So those are our two possible triangles there. Now, if we were to figure out, well, let's say this is some sine of b again, we could figure this out. We could figure out what b is by taking inverse sine of both sides. So rather than calling this big B, I'm going to call this x sub 1. So that way my first case here is going to be this 62.7255. So my answer will give me the closest one to the actual origin there. So that means that this is my first quadrant answer. That would be this piece of it here. And if you're looking at this and you're going, how did he do this? Where did this little triangle thing come from? You can open up a Desmos and then choose Geometry tool, and then you'll be able to construct tools like this. So hopefully it will help you sort that out. So that's one scenario where this is our second our angle B with it. However, right, if we were in the second quadrant, this would be our reference angle. So what we could do then is we could take that angle, right, this inverse sine here, and we could take 180 minus that, and that would give us this. This is our second possibility, right? This is the other spot where sine of b could equal this 0.888, the other spot where it's positive with it. So I'm just going to write a couple of these decimals here. In this case, this this angle would be 117.27449. Right. So those are our two possibilities when we're dealing with this. I'm going to go ahead and plug in here respectively. So it wants the smaller one. I'm going to put the smaller one first here, and then I'm going to go over here and 117.27449. There we go. And notice I'm going further than what this is requiring. It only wants one decimal point, but I want to make sure you know where like these numbers are coming from. Now, this first column here, right, or this first row following it, would be if we were to assume that it's this 62.7225. So if we went with this case, we now need to figure out what this angle is, as well as what the side opposite is, right? So once we've locked those two angles into place, that forces the third angle in our triangle to be so much. So if we were to go with this B sub 1, what does that tell us about the rest of it? Well, we know the sides of the triangle are always going to add up to 180. So if our angle A is 41.3 and this B sub 1 is our 62.72, well then we could subtract those things over and we know what our third angle measure is here. I'm going to go ahead and write that down. So 75.97449. So if we were to force this angle, right, to be in the first quadrant, well then we've got this that we're dealing with. And as soon as we label this side here, so I'll go ahead and show how you can do labels like this for those of us that aren't in here. It tells me exactly what to do to measure the angle. I pick the leg I want, I pick the side I want, and I pick another leg, and boom, I've got it, right? The only thing to worry about would be this thing, right? Because it's measuring the actual angle here, whereas I've labeled it to be something slightly different. So if I know this angle, if I say, well, that's the first quadrant, well, then this would have to be the remaining to get me to 180 here. And I can use the law of sines once again. And because this is some ambiguous case, I'm going to go with my given pieces here, this length for A as well as angle A here. So if I were to do that, well then what I've got here is I know sine of C over C equals this sine of 41.3 over 184.6. And I could figure out what C is. I could instead of, instead of writing it like this, right, I could take this and I could rewrite it so that way my sine of C is here. So that'll take me just a moment, 184.6, right? Because you can have your side lengths over your angle lengths. And the reason why I'm doing it that way is because I'm defining what C sub 1 is, right? So as soon as I know what that I'm dealing with this C sub 1 here, I can now figure out what my side opposite it is. So this is going to be some 271.3579. So I can figure out this third side here. That would be that thing. You can imagine you're going to repeat this process, assuming that instead that B is this 117, that you're dealing with this angle measure here. So I'm going to take 180 and then subtract this 117.27 and then this 41.3 instead. So I'm going to take this and instead subtract B sub 2 off of it. And that leaves me with this 21 degrees left over. So I'm going to go ahead and copy that and move it on over. So that's this. And then C sub 2 if we were dealing with this case, would mean that we would have the same scenario where we have this sine of c, but instead we have some instead what we have is c over some sine of c sub 2 that we're dealing with there. And then in order to solve this, all I would need to do is multiply this over. Right, so I would multiply that sine of c sub 2 over, and that gives me this 102.17 business here. I'm going to go a couple more decimal points so that way I have all the things that I need. I hope this was helpful. By all means, if you have any questions, please let me know. I hope you are all well, and have a good day.